Alright, so this section of 5, section 504, is on a very special type of counting technique, right? Counting is important, so we have to be able to count stuff in order to find probability. Alright, so permutations and combinations. Alright, so again, these are very specific types of counting techniques to use, and only to use, so you can only use permutations and combination when one very important thing is that you cannot select any item more than once. So this is only used in the cases where there's no repetition allowed, no replacement, nobody can be picked more than once. Alright, so you can only use these in those cases. Again, you cannot repeat a person or an item. Alright, then it matters, then once that's established, alright, I cannot pick the same person, same item more than once. Then there's a difference between permutations and combinations, the counting techniques. Permutations, which is the first one we're going to look at, we've actually done examples of permutations without calling them that. A permutation is when you're selecting an item and order is important. Alright, order matters. When order matters, that means there's a different rank, a different placement. When you select things first, second, and third, it's different, right? It matters who's first, who's second, who's third. When you line them up, it matters. So order is important. Whenever you have a sequence, right? Your code, right? If you type in a code, your phone number, the order you type it in matters. You just can't randomly type in numbers. Alright? And so when we're arranging things in a distinct order, and you cannot repeat items, that's the permutations case. Alright, so there's two types. There's the permutation when you're selecting everybody and ordering them, and then there's the permutation type when you're selecting just some of the group and ordering them. So the first example we're going to look for is the permutation. Suppose I start with n items. So n would be the total. N is how many items we have. And we're going to range all of them, and we're going to figure out how many different ways can I take those n items and reorder them, because again, permutation order matters. So one order is different than another order. So a simple example, so again, how it's set up is what we call this is n factorial when we do this. So n factorial, that's when we subtract every time. Alright, so it'd be, if we start with 10, then the next number would be 9, then the next number 8, 7, 6, 5, 4, 3, 2, until the last place is 1. And so these are the outcomes, the permutations. If you go back and look at the stuff we did earlier, the permutations are all the outcomes where when we multiplied, we subtracted 1 in each case, right? Without replacement. And order mattered, like we were doing a sequence or code. Alright, so a simple example, suppose I have the letters X, Y, Z, and I want to come up with the code for X, Y, Z. And I want to know how many different ways could I organize. So again, this is the count, the number of ways I can organize those 3 letters. Well, it is a permutation. I have 3 distinct letters. We want to arrange the letters. Arrange means order. Alright, I want to order them, meaning X, Y, Z is different than X, Z, Y. And so this is a permutation type. How many ways can I do that? Well, there are 3, so n is 3. And so to do this, it would be n factorial, which there's a factorial key. All calculators have them. You just have to figure out where your factorial key is. Most of them, it's located under the probability button on your calculator. For simple scientific, there's usually a probability key. For your graphing calculators, you have to actually find that. That's usually under the math key, and then you have to scroll over to probability. Alright, find the factorial. The factorial means, again, you're going to do this. So in our case, it's 3 factorial, which is going to be 3 times 2 times 1, which comes out to be 6. There's 6 ways. And that should make sense. There are 3 letters for the first position. Once I pick one, there's only 2 left over for the second position. And once I pick that one, there's only 1 left over for the last position. And so there are 6 ways to do this. And I'm actually going to list them over here. I'm just going to go through and list them. And so what we mean by order, one way to arrange the letters is X, Y, Z. That's one order. Another way to arrange them is X, Z, Y. That's a different order. Y, X, Z. That's a different order. Y, Z, X. Z, Y, X. And Z, X, Y. And those are all of the different ways that we can take those 3 letters and reorder them, rearrange them. And again, when in a permutation, if this were code, each one of those would represent a different code, right? You have to, suppose your code is just those 3 letters, right? So you'd have 6 ways you could set up your code. Or if somebody was guessing it, they would have a chance of guessing it 1 out of 6 times. Now, let's suppose we do the entire alphabet. Alright, how can I arrange all, and again, all of the letters in the alphabet, which means my n now is 26. And so I'm going to take all 26 letters and figure out, well, how many different ways can I take all 26 letters and rearrange them? How many different groups of 26 will I get? And then again, all it has to do is, remember, just change one order, and you've got a different group. So B to A, so if you go B, A, C, D, F, G, all the way down to Z, that's a different order. Or if you switch Z and Y, that's a different order. And so this is going to be a very large set. This is, again, 26 factorial, which would mean 26 times 25 times 24, right? You subtract 1 each time, all the way down to 1. Alright, so again, 26, 25, 24. If you type it out on your calculator, it's a very, very, very large number. It's 4.03 times 10 to the 26. So that means it's 4, if I leave off the 03, with 26 zeros after it. That's a very big number. So big that we don't have a name for it. So there's a lot of ways we can reorder it. Alright, so that's if we're selecting all. So n would represent, I take n all, so that's all my items, and rearrange them into n distinct ways. So you're taking all of them and rearranging them. Alright, so that's one way. And that way we use the n factorial case. What if I don't pick all of them? So, like my first example, I only picked 3 letters of the alphabet and rearrange them. So suppose, instead of picking all of them, we're only going to select a group of them. Alright, so we start with n. N is still the number of, so n represents the total number of items. But instead of rearranging all of them, we're only going to pick a small group of them to rearrange. Alright, so in this case, we don't go all the way to 1, we stop. Alright, we stop at a certain number. Now the formula does use factorials. And again, the formula is given to you on the formula sheet, although almost all calculators have a permutations key in it. If you have a TI-30, not TI-80, TI-30, right, there's a probability key, and it has, and the permutations key is labeled NPR. If you have a graphing calculator, again, it's on there too. It's under the probability key. And again, it's NPR. Some calculators, depending on how new or older are, you have to type in N first, then select this, and then type in R. So in some calculators, you'll have to hit your number, then pick the permutations key, and then put in your R. Alright, or you can use the formula if you know the factorials. Alright, so again, NPR should be located on almost every type of scientific calculator out there. You just have to know how to find it. Alright, there's lots of videos out there to show you how to do that, and since everybody could technically have a different calculator, you look up the way you can do it on your calculator. Alright, so an example. So again, on the calculator, it's permutation N2R. N is the total, R is how many you're picking. Alright, so an example, 10P6, meaning I would have started out with 10 items total, or 10 people total, and I'm going to pick R of them, which is 6 in this case, and then reorder them. That makes it the permutations case. And so if you're using the formula, it would be 10P6, so it would be 10 factorial over 10 minus 6 factorial, which would be 10 factorial over 4 factorial, if you wanted to use the formula. Again, least likely to make mistakes, but might as well just use your calculator. So find how your permutations, again, it's usually under the probability key. PROB is usually how it's shortened in a calculator. Some of them you can go ahead and just, it'll have, open boxes and you can plug your numbers in. So you'd plug in your 10 and your 6 and hit enter. Those are the newer calculators. If you've got an older calculator, you often will have to do N first. So you'll have to type 10, then go select your probability permutations, and then type R in, which I don't know, I hit 3 instead of 6. So yours will look like this. So again, just depends on your calculator. Figure out how to do it. Like I said, there's YouTube videos for every type of calculator you can have. Casios, 83s, 84s, Inspires, TI-30s. Again, you find your calculator and figure out how to do the permutations. When you do, it should come out, in this case, 151200. Alright, so 151,200 ways to take 10 items, pick 6 of them, and reorder them. Alright, so there's a lot of group. Permutations tend to be large, because when you reorder, again, you don't have to reorder 2 of them in order to get a different group, a different set. Alright, so I'm going to look at this in more detail, and then we're going to get to, so permutations is the first one. So we're going to look at permutations again in sort of an example to lead us to the next counting method, which is combinations. Alright, suppose I have 3 people. I have Ann, Bob, and Carol. Alright, so I have 3 people. I need them to fill the position of president, secretary, and treasurer. Alright, develop a counting procedure to determine the number of ways this can be done. Is it a permutation? Yes, it's a permutation because there is an order based on rank. Right? If you're picked for president, that's different than if you're picked for secretary, and that's different if you're picked for treasurer. This is the all case. I have N people, I have 3 people to fill 3 positions. So I'm taking 3 people and filling out 3 positions. So my N is 3, and I'm picking 3 of them to fill out 3 positions. Order matters, so this is a permutation. So this is one of those outcomes where I'm selecting all of them. So again, you could just do the 3 factorial, and it should make sense that's the case. I have 3 for president, 2 for secretary, and 1 left over for treasurer, and so there are 6 outcomes. Now, if you use the permutations key on the calculator, it should give you that as well. You would type in 3 for your N and 3 for your R, and that will also give you out 6. It actually does this on your calculator. There are 6 possibilities, and so I'm going to label them. So we have president, secretary, and treasurer. So first position, second position, third position. And then my different groups, and again, I'm going to let Ann, Bob, Carol. So one way we could have president, secretary, and treasurer, we could have Ann, then Bob, then Carol, which that's different than if Ann is president, Carol is secretary, Bob is treasurer. Alright, so there's 2 different ways when Ann is president. Well, what if Bob's president? Ann can be secretary, Carol can be treasurer, or Bob can be president. Carol could be secretary, Ann can be treasurer, and that's all the ways Bob can be president. Carol's president, Ann could be secretary, Bob could be treasurer. Carol's president, Bob could be secretary, Ann could be treasurer. And if you count them up, there are 6 different groups there, right? 6 ways you can take Ann, Bob, and Carol and have them in the positions of president, secretary, and treasurer. And again, it matters, right? Because somebody in a different position would have different rank, all right? So order matters. So that's a combination, or sorry, that's a permutations example. All right, so the next one I'm going to look at, I'm going to up it up. All right, suppose that we add 2 more people to the pool. All right, so we're still going to fill out the same 3 positions, but now 5 people have entered the pool. So this is the other case. So I've got 5 people, right? 1, Ann, Bob, Carol, Dave, and Ed. So now I have a total of 5. We're still going to pick 3. So R is 3. So this time we don't use the factorial. We're going to use the permutations. It is a permutations because order matters. And so we're going to use our permutations key on the calculator. Again, it depends on your permutation. If you can just type in 5 permutations 3, type that in. Or if you have to do 5 first, select your permutations key, then type in 3. Or you could technically you could also fill out the formula if you wanted to. So that would be 5 factorial over 5 minus 3 factorial. Should give you the same answer. Should give you 60. There are 60 ways to take. So again, permutations start to get big the more numbers you add. Right? When we only had 3 people, there were 6 groups. When we add 2 more, just 2 more people, it ups it from 6 to 60 times 10. Gets it times 10 bigger. And I would never ask you to list it, but I wanted to list it here so that because I wanted to lead us to the next answer, problem part 3. So here's the list of all 60 ways I can take 5 people, fill the positions of president, secretary, and treasurer. All right, so basically you take each group and reorder them. Right, so those are all these. So there's all 60 listed here. Where we take Ann, so again, Ann, Bob, Carol, Dave, and Ed. I listed them because I want to get to the next question. All right, so the next question is, again, I have the same 5 people. All right, same 5 people. But this time, I just want to select a committee of 3. So I'm starting out with 5 people, which is still an N, and I'm going to pick 3, that's still R, for a committee, which is just a group of people, right? The committee. There's no order to it. If Ann, Bob, and Carol are picked for the committee, they're on the committee. If they're picked in that order, they're on the committee. So if I have Ann, Bob, and Carol, that's the exact same thing as if I picked Carol, Bob, and Ann, right? It doesn't matter what order I picked them in. Those 3 people are on my committee, right? There's no difference in the committee because there's no rank involved. There's no first, second, and third place. It's just a group of people. So this is just a group where order is not important. Doesn't matter, right? And Bob and Carol are on the committee. No matter how I pick them, they're on the committee. And so this problem's different because, again, it's just a group of 3 with no importance in order. A group and Bob Carol is the same group as Bob, Carol, Ann. Doesn't matter, they're all on the committee. Alright, and the committee responsibilities land on them. In this case, it is not a permutation. What it is, it's the other counting technique. It's a combination, which I'm going to formalize it in a second. All right, so just using what we have, using the answer from the part 2, how many possible committees are there? So again, order doesn't matter. And so you just find how many different groups of 3 there are. Well, they're basically by the columns there. I did it on purpose. So the first group's Ann, Bob, and Carol, and then it's reordered, but I don't care. Ann, Bob, and Carol's in my group, so how it reorders, it doesn't matter. All of the people in that first column, it's the same group. This is the same group. Oops. And so I just need one of them. Same thing with the next one, Ann, Bob, Dave. Different group, different committee. All right, but I don't need to reorder it. Ann, Bob, Ed. And so if you look at them, they're all the... I just picked the top ones, although technically I could pick any of them there. But there are 10. If you count the ones that I've highlighted, there are 10 different groups. And basically, you take away the reordering. All right, I don't care how they're ordered. Those would be the 10 different committees if I started out with 5 people. All right, so if I had 5 people to pick from, there are 10 different committees if we start with 5 people and select 3. Alright, so in the next video, I'm going to start with the combinations, alright? So that was an introduction to permutations, foreshadowing combinations, and so I'm going to go ahead and pick combinations up in the next video.